So we finished the first stage, that is the pre-mechanical computer. Then we start with brains. Then we talk about some of these mechanical pre-mechanical tools. Now we're going to talk about some example of these machines that we use to count and interpret data. So let's start talking about the two extremes. Yeah, in the beginning we will talk about the abacus, and we will talk about many different mechanical computers up to this one that is full of leverage um, and cranks, and it doesn't have an engine, but you used to have to move it or use steam to move it. But those were example of mechanical computers that use they were computer devices that perform calculation using physical mechanisms. And so the first one is the abacus, that it was invented long time ago. The other one is the difference engine from Charles Babbage, that is a little bit more than 200 years old. And in both cases, they don't rely on electricity or electronic circuits to process the data. So let's start. So as I said before, when we were living in small tribes, the number of things that we have to count were very small. However, when we start moving to larger cities, like in Egypt, in China, in Mesopotamia, uh, these large towns require, for example, that you start counting how many people there were in that city, yeah, to know how much food there will be, to know, for example, the each one of the heads of cattle, how much cattle each person will have, yeah, and for that reason, so the increase of the scale in our society become greater than the capacity of a single person to keep in mind or to manipulate. So for that reason, we start using this tool, and that is called the abacus. That is very simple. Each one of these bits, when I had an abacus, I used to learn to count to 40. Yeah. However, if you see, they did it in a different way. They did that each row will represent a different power of 10. In other words, here you will count from 1 to 9, here to 10 in tens, here you will count in hundreds, and here you will count in thousands. So you will count up to 9,999. So let me show you. So remember, here you have a yellow row, then a white row, then a red row, and then a green row. And so in the first one, you will count the first 9 digits, then you will count 10, 20, 30s, and in the next one, hundreds and thousands, and so on. Okay, so this simple machine, the abacus, give a lot of computer power, and remember, similar to your computer that has a memory, and it would also have um, some kind of memory, because you are just keeping those things, and it helps you to not only to count but perform some operations. Yeah, I'm sure that you know that if you move from the side or to the other side, you will be also able to produce to apply simple operations like addition, subtraction, multiplication, and division. So as I was saying before, this was a great tool, and we're going to use it to compute a number, to calculate a number. So the number will be 1,251. And I want that you try to calculate it, yeah, using the abacus. So it will be pretty easy. So first, here you see that the 1,000, you will have only one here on the top, 200. So here you will have two here, 51. So you will have five in this row and one here. Okay, and in that case, for example, this can be heads of cattle, of cows that some people have, or the one that are required for this town to survive. And you can use this as a manual calculated tool that can help you to do basic arithmetic operation, as I said before. So for example, if you need to add something, you will just add two more bits to the right, and for example, if two cows die, so you will remove the bits from that in that direction. And to multiply and divide, you will also do this kind of operations. So now we're going to talk about John Napier. Again, we are going to uh, tried to focus on mechanical devices that they were used to calculate numbers. Yeah, we're going to, there are so many more. And here we're going to talk about this Scottish man that you can see in the picture, that his name was John Napier, and he was from Scotland, and he was a mathematician, a physicist, astronomer, even a theologian. And he's very famous because he invented the algorithm. And why he did that? Because he wanted to simplify complex multiplications and division. And if you remember your calculus one, uh, the the rules of logarithm allow to make something that it was very complicated. You can make it, simplify it, and subtract it, and or add it depending on the rules of logarithms. So it was great. It helped a lot because at that time we didn't have computers, calculators, so you have to do everything by hand. And he also create lookup tables. This is something that we don't have anymore in the textbook. There were books, entire books that they already have the calculations. Somebody did it. So why somebody has to do it again? So he invented those things, and there are many lookup tables. And another thing that it helped us is that those calculations were very tedious, and sometimes you can make a lot of mistakes. So if you have it in those lookup tables, sometimes a statistical textbook can still keep some of those tables, but right now everybody don't use it anymore. He also will be remembered to produce this calculator that it helped a lot to simplify multiplications and division, and I'm going to show you a video that do that. So let's start watching this video about Napier bones and the calculator.
Napier's bones consist of wooden or bone rods with figures engraved on them. Numbers are formed using these rods and then calculations carried out on them in a straightforward way. Let's see how Napier's bones can be used to solve a multiplication problem. Say we want to multiply 243 by 6. First we take the number rods 2, 4 and 3 and put them next to each other to form the number 243. Then we put another bar called the index rod marked with the numbers 1 to 9 to the left of the rods showing 243. To do our calculation, we focus on the intersection of the number 6 on the index rod and the number 243 shown by the other rods. When we add the numbers in the boxes separated by lines in the intersection from top to bottom, the result comes out.
Now we're going to talk about slide rules, and maybe you have seen some of them, if maybe your grandparents used them, and I'm going to show you again another computational tool that we used in the past. Even I think 50, 60 years ago, people still use them. So this slide rule represents a significant advancement in early computer tools, and I'm going to show you this. Please try to divide 21 by 75. And I know that is annoying if you have a calculator. Yeah, you just have to see it and start thinking, and you can even make mistakes because it's something that takes time. So what people did is to have this type of rulers that you see, they start moving. You find the two numbers, and then you move this ruler and find the answer. So in other words, you find first the 25, then the 75 as is shown here, and later you move the other component of the ruler here that it will show you the answer. Okay, so pretty easy to use, yeah, and you have it for multiplication, for division, for logarithms, or for different type of mathematical operations, yeah. So they were very old, yeah. Look, 1621, 1623, and you have different types, and they were still used up to, yeah, a few decades ago. So here you can see an old slide rule from the past. As I showed you before, this streamlined the mathematical operation in the pre-electronic era. It allowed to make less mistakes. Yeah, it was just, for example, to multiply something, you just have to move, to find the product, you just have to move one and the other ruler and move this purple stuff. So it was very convenient and it speed up a lot the operations. Okay, now we're going to talk about another mechanical device used for computation, and this is a mechanical calculator created by Pascal. So let me show you here what is happening. You have here all these dials, and if you see when you move those dials, the numbers start changing, and it start computing numbers, yeah? And you have all these levers underneath that are moving, and they are causing that the other ones start moving. So when you add something, if you go over 9, then it will move the next one and the next one, or when you subtract, they will move in the opposite direction. So it was an incredible machine to do this type of calculations. Okay, I'm sure that you will find different videos that talk about this in more detail. I'm just showing you this as a novelty that I found very interesting. And I know that maybe you have heard about Pascal, that he was a French philosopher and a mathematician that created this mechanical calculator, that it was a first version of what we have now with the um, digital calculator. And why he did that? Because he wanted to help his dad. His dad used to collect taxes, and a calculator like this used to can help him to do the work much easier without any mistakes. And again, remember, all this old technology use a dial, and maybe in the 80s, from the 50s to the 80s, I guess, we have these dials in our phones. We don't use it anymore. So all these devices, everything became digital, and now I'm sure that your phone, none of your phone have this. Actually, land phones are, I think most of them, they are disappeared. Okay, so maybe you have never heard about this guy, Charles Babbage, and he did something that is amazing. He is considered one of the fathers of computer, and he foreshadowed the modern computer, the appearance of the modern computer for more than a century. Yeah. So what happened is that this guy that you see here, he had an idea. He was an astronomer, a philosopher, mathematician. He was doing a lot of things, and he found that calculating um, polynomial functions like these that have many variables that you can subtract, add, and have a lot of operations there, yeah, were very difficult to calculate. So he was going to invent a machine to do that for him. So here you have this is the video that I showed you before, that show when they built the machine. Finally, somebody made it, and it actually worked. He couldn't finish this machine because of lack of funding, but then they made it and it actually worked. So remember, uh, what this guy did, Charles Babbage, it was to design to he designed to Yes, he decided to automate the calculation of polynomial functions, building this machine that generate mathematical tables. And in this case, a polynomial function is a mathematical expression that consists of many variables and coefficients that combines using addition, subtraction, multiplications, where all these variables are raised to non-negative integer powers. Okay, so I know that it's sound a little bit technical, but I just want that you know that this is what artificial intelligence will also do. It will play with this polynomial function in many cases. And remember, it was considered the precursor of the modern computer. I'm just going to summarize a lot of this information. Yeah, this is called the difference engine. Yeah, but if you, in the crash course, I will leave the link of early computer. They talk about this, and they talk about in much more detail about this. Charles Babbage, that I'm summarizing a lot. Then he had a second version of a machine called the analytical engine, and in the later versions, here is the analytical engine. Yeah, this one in the later versions he had a stem. Yeah, so the stem was creating the power, so there was no need that somebody move it. The stem was going to move it. And remember, it's fantastic just to think that all of this was creating just moving gears and levers, and doing all these calculations. Yeah, so how this work? It was just with mechanical devices. Yeah, like and that you have to turn a crank, or in later versions a steam was designed. This one, different from the previous one, the different engine was never built. And again, this was an early version of a computer that, even in addition to calculate the polynomial functions, it can print the results. And it used the decimal digits, and it was able to calculate up to 31 digits, what is incredible. So another very important person in the early computation in the mechanical devices is Lady Auguste Ada, and she was very important, and she was the Babbage owes a great debt to Ada. Why? Because in addition to be a brilliant mathematician that helped him a lot in his work, she was the one who documented his work, and thanks to her documentation, later this inspired many scientists that they were the one who actually built the first generation of computers. In addition to that, she was considered the first programmer because she was the one who helped to create the program so these machines, the difference engine and the analysis engine were able to be used. So she was the one who created those programs. So we have a lot of that to Ada. Now we are going to start talking about a transition that a technological transitions in computers, that it will finish with these mechanical devices and start moving into the digital era. And there were an invention and a discovery that it was very important. It was the discovery of the electricity and the invention of light bulbs. Yeah, so electricity was fundamental, and light bulbs were fundamental. And I will show you in a second why I didn't know, but light bulbs in the past, they were key for the development of computers. So these two, the discovery and the invention of the light bulb were very important. They were milestones of after centuries of discovery and exploration. And in particular, you can see here Edison, that he produced light bulb using a carbon filament, and created a vacuum, and this allowed the increase of the lifespan of the lifespan of this light bulb, that it made it cost effective and productive to be sold. So in addition to the electricity and the invention of light bulbs, and I will talk later about the relays, we need to bring back another very important tool, that it was the Boolean operators that we took from math, and those one will be very important for the creation, for the development of computers. And if you have heard about Boolean operators, are logical operations like and, or, and not, and that you generally use when you are searching something on Google, and they are very important. The main application, or one of the main applications, is in the construction of circuits in computers. So remember, what is a Boolean operators are logical connectors. Yeah, and here there are three, there are more, and there are more combinations. And the main idea, they are used in programming, mathematics, and search engines. And the application in particular to computer is to use electronic circuits. Yeah, so here you can see OR, and here OR. And why this is important, because in the next section where I'm going to show you a video of how we start using these electric devices, to make the computation for us. So it sounds like magic, and when I saw that, I thought like that is very interesting. So what we are doing, what computers are doing, is using electrons to trick them to do the calculations for us, and they can do it much faster. So please watch the video. Again, this is a short version of the video, and you can watch, I will have the link there, so you can, if you're interested, you can watch the entire video that is 20 minutes. So now I'm going to play a video for you. Let's see if YouTube allow me to play it. It's from a great science educator, and he's going to put all these things together: the Boolean operation, the electricity, as well as the light bulbs. Yeah. Later we will talk about relays and other things, but here the idea that you start trying to see how we start changing, yeah, from mechanical devices to use electric circuits to start doing computation. That I found inspiring. So hopefully you can play it. If not, you can watch the video here in this link.
You're powering up this triode
warming
here.
up. You can see it warming up there.
So the yellow is the input and the...
Yellow is the input, purple's the output. We have essentially a 2 volt change on the input giving us, what is this, 5 volts? So 5, 10, 15 volt change on the output.
For this demonstration, we were only using 24 volts on the anode. If we had used a higher voltage, we could have got a lot more amplification. And people did. This was the device that allowed us to call long distance for the first time. Using vacuum tubes, the first transcontinental call from New York to San Francisco took place on the 25th of January, 1915. Whoa.
Yeah, there we go. Should be 10 volts.
It's hard to see the grid here because, just like with the cylindrical diode, the best configuration for a triode is to have a cylindrical configuration. The anode is on the outside, the grid is cylindrically inside that, and the cathode or filament is in the center. The invention of the triode was incredibly important. Radios, TVs, whatever electronics people had were powered by vacuum tubes. You would have had so many in your house, even up until the 1960s and 70s. But vacuum tubes weren't done revolutionizing electronics. In his 1937 thesis, Claude Shannon found a connection between electric circuits and a branch of mathematics known as Boolean algebra. Working in the mid-1800s, George Boole was trying to find a mathematical foundation for logic. Under his system, a true statement was represented as a 1 and a false statement as a 0. And Boole also developed a few operations, like AND. If both statements A and B were true, then the output would also be true. What Shannon realized is that Boole's operations could be represented as electronic circuits, that there was an equivalence between mathematical statements and electric circuits. All you needed to realize these circuits in the real world were a couple switches. That same year, 1937, George Stibitz built the first digital calculator. It could add 2 one-bit binary numbers. That is, it could add 2 numbers so long as they were either 0 or 1. The calculator worked using a relay, that electromechanical switch from telegraphy. There were 2 inputs. If they were left open, the input was 0. If closed, it was a 1. The output was shown with 2 light bulbs. If no lights were on, the answer was 0. If the output light was on, the answer was 1. And if the carry light was on, the answer was a 2.
Okay, I want to stop at this point in this presentation, yeah, and to start moving into the transition between mechanical computing to digital computer, but we will do that in the next video. And just to remind you, we just finished in the first video the pre-mechanical era of computing, and here, as you see in the videos, we used to compute, we used to count with our hands, we used to use bones or write things in caves in the beginning, and later we went to a transition where we use different devices, and I show you multiple devices. Again, I didn't talk about many devices, yeah, I just talk about devices for calculation, but there are many that they were used, for example, for navigation in the ocean, for firing cannons during war. There were so many computer devices, yeah, there are thousands of type of watches that they use for calculation. And now we are going to talk about this transition to the digital computer era, and we are going to talk about these electromechanical computer devices to later move into the digital computers. But with this, we are done with this video, and I hope that you join me for the next one.